Hi everyone, good afternoon. I'm Sumudu Liyanage. I am a software engineer at WSO2. So today I will be talking about Helm charts and Flux Helm controller. So in this talk, I will be going through the motivation behind Flux and Helm, the Helm charts, Helm repositories, the architecture behind Helm, and Flux Helm controller. So I will start with the typical question that everyone asks. So what is Helm? So Helm is a package manager for Kubernetes. So if I explain the idea of a package manager, with package managers, we can simplify the installation and management of software packages. So if you have used Python, you have this package manager called pip, where you can install a lot of software packages, a lot of Python packages. And if you are a Mac user, you have this package manager called Homebrew. So you know, if you are a Mac user, how easy it is to install and manage all software applications with Homebrew. Like that, like for macOS we have Homebrew, like that for Kubernetes we have Helm. So with Helm we can manage the installation of Kubernetes applications, even though they are quite complex. So let's think about a scenario like this. You have got an application, and you want to deploy that application in your Kubernetes cluster, and you have deployed it. You can see 4 services are running, and you want to deploy an Nginx ingress controller in your cluster to manage all the traffic to these different services. So you start to develop this Nginx ingress controller by yourself from the scratch. So you will have to write whole YAML manifest for service accounts, cluster role bindings, deployment, services. You can imagine how tedious task it is. And also, before you are going to deploy it in the cluster, you have to test it as well. And think that someone else also needs an Nginx ingress controller to deploy in their cluster as well. So that person has to go through the same scenario, writing all manifest by themselves. So, but if you look at some applications like Nginx, MySQL, their use case throughout the whole cluster is quite same, right? So it makes perfect sense that someone create these YAML files once and package it up and stores in a place where everyone can get there and download and use them. So such a bundle of YAML files for a particular application is called a Helm chart. So this is the story that I have been talking. So the Helm chart is a bundle of YAML files for a particular application, and the developer creates a Helm chart and pushes to a Helm repository. So Helm repository is the place where all the Helm charts are going to be stored. So before moving forward, I will introduce another terminology that is commonly used in Helm world, that is the Helm release. So Helm release is a running instance of a Helm chart. So after installing a Helm chart, it will result a Helm release in a Kubernetes cluster. So I have talked a little bit about Helm repository. So it's basically a collection of Helm charts. So developers can create Helm charts and push to the Helm repository, and users can just pull them from the repository and use it. So Helm charts can be in Helm repositories can be in 2 types, public or private. The Helm charts within a public repository can be accessed by anyone over the internet. And Helm charts in a private repository is normally accessed by people in a particular organization or project. One of the famous Helm repositories is Helm Hub, which is maintained by the Kubernetes community. And it's a public Helm repo. And other than that, we have Bitnami and Stable Charts. They are also quite popular repositories. So this is what I have talked up to now. So Helm developer creates a Helm chart and uploads to the repository. And we have the user. In most of scenarios, user is a developer too. So that person has installed Helm in their machine or the server. So basically, when you are installing Helm in your system, Helm client is get installed. And then the Helm client is responsible for accessing the repositories and downloading them and installing those manifests to the Kubernetes API. Here, I specified that we are installing the Helm client. Actually, I am referring to the newest Helm version, that is Helm 3. But previously, we had Helm 2. Its architecture is quite different. So I will be going through the architecture of both Helm 2 and Helm 3. So this is the Helm 2.0 architecture, the previous architecture. There, you can see, instead of with the client, we also have a server. So we have a Helm client and Helm server. So Helm client is basically a command line interface where users can interact with the Helm commands, Helm install, everything. And we have the Helm server. We also call it Tiller. It is running inside the Kubernetes cluster. So it basically communicates both with Kubernetes API server and also Helm client. So if I say this Helm client and Helm server is basically talking with using this gRPC protocol. And yeah, so Helm server has so many capabilities. So it has a lot of responsibilities as well. So it is basically doing the release management. So with the Helm server, Tiller, we can install the releases, upgrade, rolling back, uninstall. We can do everything. So it has so much capabilities in the cluster. And also storage. This Helm server has a history of the Helm releases. So it is used for release management as well. Then the other service provided by the Tiller is chart rendering. So in Helm charts, we have these values files and templates files. So by Helm server injects these values files into the templates and create Kubernetes manifest, which can be directly sent to the Kubernetes server, API server to deploy. Somehow you can see Helm server, which is called Helm Tiller, has so much power within the Kubernetes cluster. It can do install, can do like rolling back, upgrading. So it has so much power. This so much power led to so much security issues. So in Helm 3.0, they removed Helm server and came up with this client-only architecture. So to go to this architecture, the Kubernetes API server was also evolved such that the component outside the cluster can communicate with the Kubernetes API server in a secure way without the help of a server component running inside the Kubernetes cluster. So that was also motivation for this Helm 3.0 architecture. So yeah, let's look at some of the Helm commands that's widely used. There are a lot of commands that I have selected some very frequently used things and put there. So before installing a Helm chart, you have to add a Helm repository. So you can add a Helm repository using this Helm repo add command, giving the repo name and URL. Then you can list all the repos added with Helm repo list, and you can remove any Helm repository with Helm repo remove command. And after adding a Helm repository, you can now install Helm charts. To install a Helm chart, you can use Helm install, release name, chart, and here you're free to use any suitable name for Helm release as to Helm release name. And then you have this Helm upgrade and Helm rollback commands where we can use to upgrade and roll back the releases. And you can view all the Helm releases by Helm list command. So up to now, I have described how we can use Helm as a package manager. Another use case of Helm is we can use Helm as a templating engine. Right? Imagine that you have an application where 3 microservices are running, and you want to write service YAML files for each of these services. And if you look at the template, it's kind of same for every microservice, only the values for some fields are changing. So are you going to write 3 separate YAML files for this? It would be a huge waste, right? Okay, for this scenario, we have only 3 microservices, and it's fine. But imagine like you have 20 microservices. But the template is same, but you're repeating the same thing, just with different values. So we can remove that with Helm. With Helm, we can define a common blueprint where we can apply this template YAML file directly to deploy all the 3 microservices. You can see you have this template YAML template config YAML, which we can use as a common blueprint for this. And there are dynamic values that are replaced by the placeholders. So the values can be injected with values.yaml, or else if you can do it with a command line by setting some flag with a double hyphen set flag. So I have talked a lot about Helm charts, but I said it's a bundle of YAML files, but I really did not tell you what kind of YAML files are inside a Helm chart. So this is the Helm chart structure, directory structure. You can see the my chart is actually the chart name. And under that, we have chart.yaml file, which includes metadata about the chart, including name, description, the maintainers, version, and so on. And in previous slides, I went through a little bit about the values YAML and templates file. So values files are default configuration values for the chart, and templates are like Kubernetes manifest templates. And the charts folder, this is not going to be in every chart. If this chart has subcharts, it is going to be in that folder. So every chart doesn't have subcharts, so it is optional. So let's come to the next part, that is Flux Helm controller. Flux, then we have the question, what is Flux? So Flux is a GitOps tool. What is GitOps? So GitOps is some practices and principles to automate and simplify the deployment and the management of software applications and infrastructure. So with GitOps tools, we can automate the deployment. For example, with GitOps toolkits, can identify any changes happen to a Git repository, and with that, we can automate the deployment process in the Kubernetes cluster. So, like Flux is actually made for GitOps tool for Kubernetes cluster, like Flux, GitOps for Kubernetes cluster. So with toolkits like Flux, we can automate the deployment in Kubernetes cluster. So why GitOps? So as I described, with that we can do the automation, and these GitOps tools can integrate with monitoring tools. With that, we can observe the system and identify the issues, and then we can make our system more scalable and more secure with GitOps tools. So, as I said, Flux is a tool for keeping the Kubernetes clusters in sync with sources of configurations like Git repositories. So with that, we can automate the updates, and when they are I will describe this with the architecture of Flux. So here we have several components: source controller, customized controller, and Helm controller. And all the components are not in this diagram. There are components like notification controller. So source controller watches these Git repositories. And when any changes are happened in the Git repository, it notifies customized controller or the Helm controller. It doesn't go to communicate with Kubernetes API at that time. It notifies customized controller or Helm controller. If it is the change in the Git repository was related to a Helm related application, it notifies Helm controller. Otherwise, it notifies customized controller. And the Helm controller is responsible for applying these new CRDs to the Kubernetes cluster through the Kubernetes API. So if you look at the Flux Helm controller specifically, so they have the source controller, and in the Git repos, normally in this Helm situation, we have the CRDs for Helm repository and Helm release. Those CRDs are stored in this Git repositories, and when there is any change happen in those repositories, like we can have new code, like that. And in that situation, the source controller is notified, and then it notifies the Helm controller that with the new CRDs, and those CRDs are going to apply to the cluster through the Kubernetes API. So if I explain the CRDs, normally we have in Helm, one is Helm repository. So before adding charts, we have to have a Helm repository. So we define CRDs for Helm repository. You can see under metadata, so you can see the kind is Helm repository, and under metadata, we have the repository name as Bitnami, and the namespace where this Helm repository YAML is going to deploy it. And under spec, we have the URL to the Helm repo. And again, we have the Redis Helm release CRD. They are also under metadata. You can specify the name of the release, then the namespace, and we have a section called spec. Under that, there is a section for chart, where you specify the chart details. Here, I have used Redis chart for this example, and the chart version, and you can reference the Helm repository as well. And then you can define these intervals and the values file. Here I have used this values YAML and made a config map, and like that. So, yeah. So Flux Helm controller extends the capability of Flux to manage Helm releases in a GitOps-oriented manner. We looked at Helm CLI, where everything we have to do in manually. The Helm release management should be done manually in that case, but with Flux Helm controller, we can automate the deployments and based on the Git repositories. So, so that's it. And in my talk, I basically went through the Helm, the motivation behind Helm, Helm charts and repositories, the architectures of Helm, like Helm 2 and Helm 3, and then how we can use Helm as a templating engine. And I gave some brief introduction to Flux and how we can use Flux Helm controller to automate the deployments in the Kubernetes cluster. So that's it, and thank you.